Alrighty. So what we're going to do today is you're going to start by going to, let me show this tab, this kinetic and potential energy practice problems right here in School G. Kinetic and potential energy practice problems. So go ahead and pull that up. There are 2 questions I'm going to help you guys go over on here. And then you guys are going to have the rest of the time to do this on your own. So I'm going to help you go over a few of them. The ones that I think are the toughest, and to help kind of get you started, and then you'll be good to go from there. All right, it should look uh-oh. Okay, never mind. All right, it should look something like this. Everybody see that? Is this what yours looks like too? Okay. All right, so this is what the page looks like. I attached the formulas are right here. The triangles I used are here, and the kinetic one is down here. Remember to use those to your advantage, and make sure you're trying your best on these. So I'm going to try to show you guys my screen now, so I could walk you through a couple of them. Okay. All right. Can you guys see a whiteboard with some writing on it?
Yeah.
Okay. All right. So this is the first one. We're going to be doing. All right. Where are my writing tools? There. All right. All right. So this one is number. Let me see here. This is number 4. Okay. So this is number 4. They're following along. We're doing number 4. All right. So I'm going to draw my triangle over here real quick. Just have PE up top. Again, excuse my handwriting. I'm trying to do this freehand, so it's not going to be super pretty. Mass, gravity, and height along the bottom. All right, so it says a small weight is moved from 5 meters to 8 meters off the ground. What is the change in potential energy? So it's trying to find out what the difference in potential energy is if I moved it from 5 meters to 8 meters. But the weight of the mass stays the same. Since I'm looking for potential energy, what I'm going to be doing is I'm going to be covering up, or I cross out potential energy in my triangle. That gives me m times g times 8. So if I plug that in, I have two separate heights here. And again, it's trying to find what is the change in the potential energy. It's not looking for one answer. It's looking for you to calculate two answers and then subtract them. So the first one is my mass is 3. So this is, let's call this A. All right. My mass is 3. So it'll be 3 times gravity. Gravity is always 9.8 times my height. So in the first one, all right, is 5. So I have 3 times 9.8 times 5. So if you go ahead and do that on a calculator, 3 times 9.8 times 5. That gives me 147. And that's joules of potential energy. All right, so that's A. So B is going to use the same steps, but we're going to use the different height this time. So we had the mass of the object is still 3 kilograms. So it's still going to be 3 times. Gravity is still 9.8 because we're still on planet Earth. Times. Now this time I'm going to be doing 8 because that's my second height. All right, so then there's your formula. So it would be 3 times 9.8 times 8. And that gives me 235.2 joules. So it's asking what is the change in potential energy? So now that you have both of these, you can subtract them to find out what the change in potential energy was. So for the answer, I'm going to put this in green, it's 235.2 minus 147. And that will give me 88.2 joules. And that's my answer. All right. So that's number 4. So then you can come over and you can type that in here with your answer. Make sure you use your units. Now, what you can do is, what I mean by show your work, all right? Your options for that are you can type it out. So I could have done, let's see, 3 times 9.8 times 5, right? And then you could have done, oops, 3 times 9.8 times 8 equals 'So this is what you could have done. And then put your final answer down here. Like that. So that shows me what you're doing. If you ever have to divide, use the slash. You could also do the insert. You could do a drawing and you could draw it out. You could use the equation bar here and you can type that, make an equation out of it here. All right, fine. Or finally, I'm okay if you do this on a scratch sheet of paper and you take a screenshot like I'm going to, like this. And then paste it in there. All right, I'm okay with any of those options, just to show me you know what you're doing and to show me you're following the right steps. So you can take a screenshot, you can type it out. All right, it doesn't matter to me, but just make sure you're showing me your work somehow. All right, before I move on, any questions? Oh, that's trippy.
Me,
What's up?
came. I came late, so I didn't even know what we were learning on. I was just paying attention.
Okay. All right, so we are on the kinetic and potential energy practice problems. They are in Schoology in the week 3 folder. So let me show you my screen. So right here. So in the week 3 folder, kinetic and potential energy practice problems. Whoa. Oops. So if you open this document, that's where we are. We just did question 4. All right, the document should look like this. We just finished question 4. All right, trying to all right, so next I'm going to be doing question 8. We're doing question 8. This one's a little bit trickier because you're trying to solve for v squared. All right, so I'm going to share my screen again. All right, so the child does 12 joules of work pushing his 3-kilogram toy truck. What is the velocity the truck will move after the child is done pushing? So if I draw my triangle again, right, I have kinetic energy in the top. On the bottom, I have 1/2 the mass velocity squared. Kind of the dividing lines. Again, I apologize for my poor drawing. It's hard to do on a screen. So kinetic energy on top, velocity squared on the bottom, mass 1/2. All right, so this one wants us to find, okay, with what velocity right here. So that's what we're trying to find. So whatever you're trying to find on your triangle, you're going to cover up. All right, so we are going to cover up v squared. Now, remember that it's squared. What you're finding will give you v squared. So I'm going to cover this up to reveal that you're going to have kinetic energy divided by 1/2 of your mass. And that will equal v squared. So this is the equation that you're using right here to find v squared. So we'll start by plugging your stuff in. So kinetic energy is 12 joules right there. So you're going to have 12 on top divided by 1/2 times 3. So when you do this, you'll get a partial part of your answer. So it's not going to be your whole answer yet, because v squared is not the end, because you can't have a square in there. It has to be plain v. All right, so what you're going to do is you're going to do 12 divided by 0.5, which is 1/2, times 3. So 12 divided by this, and that will give you the answer of 8. So what the answer right now would be is 8 squared. All right, and that's not what we want. We want to get rid of this square. So you get rid of a square by taking the square root of something. So you're going to have to take the square root of 8, and that's going to be your final answer, which is how you get rid of that square. That's how you get rid of this. You're going to have to take the square root of your answer. So the square root of 8. I think I do this on my calculator. Is 2.83. That is in meters per second squared. I'm sorry, per second. So again, I apologize for the sloppy handwriting here. I'm trying to do this with a mouse. I should probably invest in a pen of some sort, but can't find it at the moment. So just to run through this real quick, try to highlight that. Kinetic energy triangle has kinetic energy in the top, 1/2 mass velocity squared in the bottom. What you do is you cover up what you're looking for. So in this case, it was the v. So it says, what is the velocity? Cover that up. That reveals Ke on top of 1/2 times your mass. So I reset that equation up here. And I wanted to point out that it's equal to v squared, not just v. So you're not going to be done when you get your answer right away. So what you do is then you plug in your variables. So right here is the 12 joules of energy. All right. That's going to go here. Your 3 kilograms goes down where the mass goes, down here. And then the 1/2 stays there. So when you run that through a calculator, you're going to come up with 8. So that would be representing v squared. So you need to take the square root of 8 to get your final answer, which is 2.83. All right, so then when you put this in your Google Doc, you could take a screenshot of your paper. You could take a photo of where you did your work at. You could write out this equation here on in your equation editor, and then you can put in your answer. So let me remind you how to, let me show you that real quick. So how to do that is you go to Insert, Equation, and you can start typing. So KE divided by, you could do 0.5 for 1/2 times the mass, which was 3. Okay, so that'll help you do some equations in there. Up top, you can use symbols like divided by. You could also do operations. So you could do a fraction, and you could type that in. So you can use that equations editor to type in the equation, or do it on paper and take a picture of each problem when you post it in there. All right, so that's all I have for you today. I want you guys to practice this stuff. Use the rest of the time to practice it while I'm here. If you have any questions on the problems, let me know, and I can answer them for you. This will be due by the end of the week. So once again, use this time to practice while I am here and I can help you. And then you'll be submitting it on Schoology when you're done. Does anyone have any questions?
No.
Okay. All right, you guys can go ahead and get started. Good luck, and I'll be here if you need me.